Hi everyone, again welcome to another video in this series. In this video also we are going to look into one of the problems and we are going to see its algorithm, flowchart and pseudocode. So let's go into the video. The problem we are going to do today is to find the factorial of a number. And you know factorial of a number n is written as n factorial. Exclamation symbol is also factorial. And what is n factorial? N factorial is 1 into 2 into 3 into n minus 1 into n. For example, we're asked to find 5 factorial. What is it? It is equal to 1 into 2 into 3 into 4 into 5. So 1 into 2 is 2, 2 3s are 6, 6 4s are 24, 24 into 5 is 120. That is the answer. Now what is being done here? Here we are doing a repeated multiplication. So when you write the pseudocode, you can think about what are the constructs. Sequential constructs are there, repeated constructs are there, and decision constructs are there. But here it is a repeated process. So we are actually have to use loops. We are implementing a loop where each time we are going to multiply one after the other. The algorithm for this particular problem, I will step 1 start. Then we have to find the factorial of a number. The number is not given. If the number is given like 5, I can write num equal to 5. But here the number is not given, so I have to get the value of the number. So I will store the value, get the value on the variable num. So num is the name of the variable. Next is initialize a variable fact equal to 1. See, I have to store the result. So the result will be stored in a variable. And the variable name is fact. Now here I am making fact equal to 1. You might ask why fact equal to 1? Why can't fact equal to 0? Now this is a repeated multiplication process. So when you have to do repeated multiplication, if your initial value is 0, the next value will be 0 multiplied by the next number, which will be obviously equal to 0. So if you make the initial value 0, then your final answer will also equal to 0, because it will be 0 multiplied by next number multiplied by next number, and 0 multiplied by any number will be the answer will be 0. So that is why I am giving the value fact equal to 1. So always remember, if it is repeated addition, as we have seen in the previous problem, if it is repeated addition, the initial value will be equal to 0. And if it is repeated multiplication, the initial value will be equal to 1. So this is a very important thing you have to consider. If it is repeated multiplication, so this is something which you have to see. If it is repeated addition, the initial value should be equal to 0. And when it is repeated multiplication, the initial value will be equal to 1. So that is the meaning of this step. Initialize a variable fact equal to 1. Okay. Now next is, see, I need to continue this multiplication. So I need a counting value. I have assigned I equal to 1. So I will be counting the entire process, because I should multiply 1, then by 2, then by 3 till n. So that count will be taken care of by I. You can see how it will take care of. Next step is repeat. Repeat till I equal to num, because I have to multiply 1 into 2 into 3 into etc. up to the last number num. So I will be using I as the checking variable or the count. So what should you do inside the loop? You should multiply fact equal to fact into I, and next step will be I equal to I plus 1. So first time fact is 1 multiplied by 1. Next time I becomes 2, so 1 into 2, and next time I becomes 3, so 1 into 2, 3. Next time I becomes 4, so 1 into 2 into 3 into 4, and next time I becomes 5, that is 1 into 2 into 3 into 4 into 5. Now if num is equal to 5, then I is equal to num. So I can stop the loop and display the value of fact, and then I can go for stop. We will see the flowchart and the pseudocode, then you can get a better grip of things. Here I have created a simple flowchart for the same. So if you have understood the algorithm, you can clearly follow this part also. So it begins with the start. It's an oval shape. Then I should get the number. So it's a parallelogram. It's an input. I have to initialize the two values, I equal to 1 and fact equal to 1. So it's a rectangular box. Then I am checking, is I less than or equal to num. Always this is a decision box, and this is a decision box to have two outputs. One is yes and one is no. So carefully you see, I is less than or equal to num. So if it is less than or equal to num, I should do the multiplication process. So I've written the two multiplication process, that is fact equal to fact into I, and the other one is addition, I is equal to I plus 1, and goes back to the decision box. Is I less than or equal to num? So initially I will be equal to 1 and fact will be equal to 1. I is less than, so let us take num is equal to 5. So I is less than 5. Okay, so it will go to the loop. Yes. So fact becomes fact, previous value of fact into I. I value is 1. So this is equal to 1. And I value is incremented. I plus 1. So I value becomes now 2. Now 2 is less than 5. Yes. So again it will go back and do fact is equal to previous value of fact into the value of I. I is now 2. So it is 2. Now I is incremented. I becomes I plus 1, which is equal to 2 plus 1, which is equal to 3. And 3 is less than 5. So it again does fact equal to the previous value of fact to the new value of into I, that is equal to 6. And I is incremented. I becomes I plus 1. So 3 plus 1, 4. And 4 is less than 5. So again it does fact is equal to the previous value of fact into the new value of I. So it is equal to 24. Now I is incremented. I equal to I plus 1. I equal to 5. Now what is that one we are checking? Whether I is less than or equal to num. Okay, now I is equal to num. So it will still continue. Yes. So the value of fact becomes 24 into the new value of I. So 24 into I is 120, and I becomes I plus 1. So it becomes 6. Now check, I value is 6. 6 is not less than or not equal to 5. So the condition is no. So it will print the value of fact So 120 will be printed and your program will come to an end. So this is how this flowchart is going to work. We have already discussed that this is a repeated construct has to use. So there are three types of repeated constructs, like for loop, while loop, and repeat until. Now here I have written a for loop construct. Let's see how it can be done. So I already told you that this is a repeat construct has to use, and repeat construct can be done using for loop or while loop or repeat until. So I've written here for the for loop. So if you've understood the algorithm and the flowchart, it will be easy for you to write the pseudocode. So this is a pseudocode. I will begin with start, read num, fact equal to 1, I is equal to 1. Then I'm using a for loop. So for, when you're using for, it will automatically increment. That is the easiness of while you use for loop. I will be automatically incremented. You need not write I equal to I plus 1. So I have written for I is equal to 1 to num. So it will be automatically incrementing 1, 2, 3, etc. So it will go like 1, 2, 3, etc. up to. And what it will do, inside the loop I have written. So I am writing inside the loop. That is why I have put a space here. So always put a space to indicate the what is going written inside the loop. So fact equal to fact into I. So we know first value of fact is 1. So it will first value of fact is 1. And when I do I is equal to 1. So fact equal to the new value of fact is old value of fact into the value of I, which is equal to 1. Now it will take I equal to 2. It will find the next value of fact. Fact equal to old value of fact into the value of I, which is 2. Again I become equal to 3. Then again it does I is not equal to, still not equal to num. So it will again do old value of fact into the value of I, which is equal to 6. Then I is equal to 4. Then fact is equal to the old value of fact into I value. So 6 4s are 24. Then I is equal to 5. So you have to do till num, that is given. So I equal to 5. So fact is equal to the old value of fact into the value of I, which is equal to 120. Now the I value is will not go beyond 6. This will not be executed because I varies from 1 to 5. So the value of 6 will not be taken. So the for loop has ended and it will print the value of fact. So fact 120 will be printed and it will come to a stop. Please don't confuse this with the Python code, because in Python code the for loop, the ending variable has a different meaning. But here we are written pseudocode. It is independent of any machine or any programming language. So it will execute up to 1 to 5. And I have also drawn the flowchart based on this pseudocode, because for loop has a different symbol for in the flowchart. So it has a shape of a hexagon. So you write the variable name here I. This is the starting value, this is the ending value, and this is the increment or decrement. So I am incrementing by 1. So in fact here it is 1 to num by 1. So it will be incrementing by 1, and if it is not equal to n, it will go to this again. It will multiply fact equal to fact into I and it will continue. So when it is equal to n, it will come out, it will print the value of fact and it will come into stop. So this is the difference in the flowchart when you are drawing it based on the pseudocode. I have written for loop, so I should use the symbol for loop. So the symbol for loop, it can be used like this. There's one input is there, two outputs, one for no, the condition is not satisfied, and yes, when the condition is satisfied. And it is given a feedback path also. So this is a feedback. When the condition is not satisfied, you have to do some process. So I will do fact equal to fact into I, and it is given to n. So this is how it is going to work. Now I will discuss one more pseudocode using the while loop. So remember, what is the syntax of while? While you write condition, and inside the while loop you will write the true instructions. Hope you remember the difference between while and repeat until. So in repeat until you use false instructions, but in while you write the true instructions. So if you have understood the previous cases, it's very easy. Start, read the number whose factor you have to find, initialize fact equal to 1, that is the variable where the answer will be stored. For counting purpose, we need I equal to 1. For loop doesn't need I equal to 1, but here we need I equal to 1 because we have to check the condition. Now while I is less than or equal to n. So check the condition when I is less than or equal to n. So it can be less than n or equal to n. So till n it will be executed. So till n this true condition is satisfied, it will do these two instructions, these two steps. So what will it do? It will do fact equal to fact into I, and I is equal to I plus 1. So if I have taken I n is equal to, so num is equal to 5, sorry, here it should be num, I less than or equal to num. So till the value of I is less than or equal to num, this loop will be executed. Otherwise it will come out and it will execute, it will end the while loop and print, and then it will stop. So I hope it is clear. So I've written the pseudocode using while. Can you try using repeat until? It's almost the same, but we will give the false condition. Inside the condition is given in the until statement. Here we have seen another problem, finding the factorial of a number. We have discussed the algorithm, pseudocode and flowchart. So work with it. Whenever you write the pseudocode, check for the various conditions to see that the loop is executed correctly. Give small numbers like 4 or 5 and check whether your loop is working correctly. That is a way to check whether your program will also be correct. So work it out, and please give your feedbacks. Please put your feedback as comments, including your name and roll number, so that we can able to interact more with you. Thank you.